All right, PCH, as we're preparing for the SAT, there are a few of us that need a little bit of a mini reteach on scatterplots, and that's what this video here is for today. And so you just took the pretest for problem solving and data analysis, and the following two questions were on it. So let's talk about these two questions. We'll look at the one on the left first. The scatter plot above shows the total number of home runs hit in Major League Baseball in a 10-year period, and there's a line of best fit shown. Which of the following is closest to the difference between the actual number of home runs and the number predicted by the line of best fit in 2003? Whenever we're looking at this data, what makes up our scatter plot is each of these individual points that we see here. The line of best fit is not representing actual data, but it's literally a line of best fit. If we had to somehow come up with some line to describe this relationship, it looks like it would be linear, and so we come up with a line of best fit that more or less fits this data in a way that allows us to predict with some sort of confidence what a value might be for any year, even if we don't have specific data for it. And so in 2003, again, it's asking us for the difference between the actual number of home runs, which is going to be one of these actual plotted points. And in 2003, it looks like that was here, as well as the number predicted by the line of best fit. So if we were trying to predict what the value would be, we would be looking at this line of best fit. And we notice, hey, there's a difference. These 2 points are not the same. And so it's asking for exactly what that difference is. It looks like my line of best fit, my predicted value is at 4,500. My actual value is somewhere between 5,500 and 5,000. Let's go with 5,250. And so the difference between those two values looks like it's about 750. So I'm going to look for an answer choice that looks similar to that, which is option C. All right, let's talk about this other graph. Again, it looks like we're given a scatter plot that also includes a line of best fit. And it's representing revenue in millions of dollars that a company earned over several years, and a line of best fit on year 4, the difference between the actual revenue and the predicted revenue is N million dollars. What is the value of N? Again, this is the same exact problem we just did, but in a different context. At year 4, we're looking for the difference between the actual value, which is the plotted point, and the predicted value based on the line of best fit, which is of course going to fall on this line. And so, again, I point out it looks like 50 is where my line of best fit predicts for me. And then an actual revenue for year 4 of about, I'd say, 55. The difference between those two is about 5. And that's the value of N for me. What you'll notice, again, I want to stamp it before we move on to you trying some problems on your own, is that the big idea with these types of scatter plots is that the line of best fit is the predicted value. And the data point that's graphed is the actual value. And so we've done a couple problems together. I want us to try some on our own now. I want you to read the question on the left and see if you can answer it for me. Hopefully you found that Y value of $550 billion, found where that intersected your line of best fit, and then went down to your x-axis to figure out what year this number of miles would be traveled by air passengers. And it looks like about 2003 or 4, which looks like answer C. Now I want you to try the problem on the right. Again, what we find is we're doing the same process. The difference between the actual value versus the predicted, which in this case, the difference of 150 and 148 would be 2, which is option B. Now I want to talk about some more general interpretations that we can make from a scatter plot. So let's look at the question on the left. This graph shows the total number of music album sales in millions each year from 1997 to 2009. It's asking us to look at the graph and see which of the following statements best describes the general trend in music album sales from 1997 to 2009. Each one of these options, as we read through, is talking about whether it's increasing or decreasing or remaining the same. And so I'm just going to look at this graph. And of course here I see, oh, from year 0 to 1, it's increasing, increasing, increasing. Then it starts to decrease slightly at year 3, decrease, maybe a slight increase, decrease, decrease, and it decreases all the way through. And so when I'm looking at these answer choices, they didn't generally increase every single year, right? Most of the graph, the scatter plot, shows us that album sales are actually decreasing. But are they decreasing the entire interval from 1997 to 2009? No. Right? They're increasing from 1997 until 2000, 3 years later. And then after 2000, they're decreasing. And so that looks like option C. And again, this, I know it's a scatter plot. There's not some continuous function that's being graphed, but this is still data on a graph. You still read the graph the same way. And so I'm going to give you a chance to try the question on the right first. What is the life expectancy in years of the animal that has the longest gestation period? We see that there is a data point at an X value of 60. That's our longest gestation period. And this question is only asking us to say, hey, at this X value, what's the Y value? And when I draw that over to my Y-axis, I see that that Y value, my life expectancy, is 3 years. Let's talk about number 11 together to finish it off. So of the labeled points, A, B, C, and D, which represents the animal for which the ratio of life expectancy to gestation period is greatest? So this question is asking for the ratio of life expectancy, which is our Y value, to our gestation period, which is our X value, and we're looking for which one of those is the greatest. Which Y divided by X for each of these points gives us the greatest value. Now you could plug these into a calculator, but I think it's pretty easy to figure out and estimate what these might be without a calculator, right? Like if I'm looking at A, 7 over 22, I know 7 over 21 is 0.33, and so 7 over 22 is going to be just below that. So I'm going to estimate that as 0.32. 8 over 44, the big thing for me is that I know 11 out of 44 would be about 0.25, which is less than A, and 8 over 44 is going to be even less than 0.25. And so I really don't need to figure out what that is because I know B is not going to be the answer. Same for C and D. 8 over 51 and 10 over 51, both of those are going to be less than 20% or 0.2. And so I estimated to 0.19, but again, of course, those are obviously less than this 0.32 ratio, which point A gives us. So point A is going to be the greatest.